Hello everyone. In this video we are going to talk about Boolean or logical operators and bitwise operators. So they're all included in the standard library, so you don't need any extra library. So Boolean operators, probably know them, but just wanted to basically refresh your mind, I would say. So Boolean variables, we can create them using true or false, or by any basically comparison operators. So here I create two Boolean operators, two double values, and another set of Boolean variables, E, F, G, H, and K. And here I assign the values to these five. So for E, I said D is bigger than C. Well, of course, 10 is bigger than 5, so E is going to be true or 1. F is D is not equal to 2 times C, and 10 is equal to 2 times 5. So when we say it's not equal, then F is going to be 0. Then G is D equals C, and D and C are not equal, so G is going to be 0. And then A and B. So look, the AND operator, the Boolean AND operator, is double AND. Okay, and the OR operator is double OR. Equal is double equal, not equal is the exclamation equal, and then bigger than or less than are clear. So I say A and B, and true and false is of course false. The other one is true or false, which is true, right? So we have a 1, 3 zeros, and a 1 if we want to show their values, and here you can see them over there, right? So this is using basically defining Boolean values and using the comparison operators, right? So if you want, we can add something here and say comparison operators. Now, we also have bitwise operations. These are very interesting. So here, everything is dealt with in the binary format. So here, for example, I have a number 25, which in binary is shown like this with 8 bits, and then number 55, which is shown like this. And I assume you know how to go from decimal to binary, right? By successive divisions by 2, right? And how to go back from binary to decimal by using powers of 2. So the first one is multiplied by 2 to the 0. The second one is multiplied by 2 to the 1, 2 to the 2, all the way, and then add them together. So here my numbers are in binary 25 and 55, which are shown like this. The first thing I do is I AND them, and look, this AND is a single AND. So when a single AND is used, okay, you use it between numbers, not between what? Boolean values. So if I want between A and B, since they are already Boolean, I have to use double AND. But between AA and BB, which are numbers and they have a binary format, I can use a single AND. And what does single AND do? Well, it's a bitwise operator, so it goes to each and every one of the bits and then AND them together. So like it ANDs the first value with first value. 1 and 1 is what? A 1. Then you have second value 0 and 1. 0 and 1 is 0. Then you have third value, that's 0, that's a 1. Again, you get a 0. The fourth value is a 0. This is a 1. So again, it's a 0. The fifth value is a 1. The fifth value is a 1. So you get a 1. And then the numbers from 6, 7, and 8, whatever they are for B, for A, they are all 0. So the AND result is going to be all 0. And now what number this one is in the decimal? Well, this is 1 to the power 0 or 1. This is 2. This is 4. This is 8. This is 16. So it's 1 times 16 plus 1 times 1, which is what? 17. So that's interesting, huh? You AND number 25 and 55 and get 17, which has almost nothing to do with those two numbers. So do not expect this to make any sense unless you look at them in the binary format. Then you can make sense of it. Well, 25 and 55, you combine them somehow, you get 17. Yes, if you are looking in the binary. Or if you do OR binary, which is a single line, then you get what again? 1 or 1 is 1 1 and 1, these are 1, so it doesn't matter whatever they are in A, the result is always 1. So you get the first three 1. The fourth one and the fifth one are 1 in A, so you get them 1. The sixth one is 1 in B, so you get the 1. The 7th and 8th, they are 0 in both, so you get a 0. So the result is, of course, 63. So 63 is OR of 25 and 55. Then you have XOR, and XOR is a caret. Remember, if you are using MATLAB, caret means what? Means power. So if you do it in MATLAB, it's going to be 25 to the power 55. It's going to be an extremely large number. But if you do it in C++, guess how much you get? Just 46. Because it does exclusive OR between the bits of one and the other. And exclusive OR is only 1 if one of them is exactly 1, the other one is 0. So 1 and 0, 1 XOR 0 or 0 XOR 1 is always 1, but 1 XOR 1 or 0 XOR 0 is 0. And if you do XOR between this guy and this one, then you see for the first one it's both 1, so XOR is 0. For the second one and third one, only one of them is 0, one of them is 1, so the result is 1. For the fourth one, again, 1 is 0, 1 is 1, so you get another 1. For the fifth one, they are both 1. Therefore, you get a 0. For 6th one, 1 is 0, 1 is 1, so you get another 1. And for 7 and 8, they are both 0, so you get 0. And so you get what? For the 6, we have bitwise not, which basically you negate all of the 0s to 1s and all of the 1s to 0s. So for AA, which is 25, when you negate it and make all 0s 1 and all 1s 0, the number is this, which is actually a negative number. It's going to be negative 26. How do you know? Well, negative numbers are different. Just look it up how you store negative numbers. The first number is always a sign number. For positive numbers, it's 0. For negative numbers, it's a 1. So since this guy is a 1, that tells me it's a negative number. And for the rest of it, the method that is used here is what we call 2's complement. So basically, the number that you get, this guy, if you add it to this one, look at that. If you add this number to this number, the result is going to be 8 zeros. The result is going to be what? 8 zeros. So we say this number and this number are 2's complement of each other. So if this one is positive 26, then this number over here is what? Negative 26. And finally, these very interesting operators, we call them left shift and right shift. These are very interesting. So here I do a left shift on B, and you also need a second thing, and that's a number. So you say shift B to the left for 1 bit, and here you say shift B to the right for 2 bits. Okay, so this number is the amount of shifts. Right here, the shift is to the left. You can look at the direction of these arrows. 1 bit, and here go to the right 2 bits. And how does it do it? Well, here is my number, right? How do I get this guy? Well, look, I shift everything 1 to the left. So what happens to this, right? This is what I have. What happens to it? Everything will move 1 to the left. So this 0 goes to the left, so it gets out of the memory, so it will be eliminated. That 0 will becomes the left side number. The 1 goes to the second number, and so on and so forth. And here, you're going to get a what? So as I said, this guy goes, and here you're going to find a gap. You're going to find 1 bit that is empty, and when you have an empty bit, it is going to be filled with 0. So you're going to get exactly what? This guy, which is what? 110. And finally, if you shift B to the right, so this is your B, and if you shift it 2 to the right, what happens? These two guys will go to the right. And right means out of the memory location. So these two will be converted into what? Will be converted into zeros, right? And not zeros, actually, they will be eliminated because they are out of. So you get this. Let me show you. These two will go out. they come here, and when they're out, it's like they don't exist. They go, and then here you get what? You get 2 empty bits, and again, when it's empty, you fill it with what? With 2 zeros, so you get this number, which is what? Which is 13. So hopefully you learn how to do left shift, right shift, not, XOR, and OR for bits to perform these comparisons, right? And, or, equal, not equal, bigger than, less than, and so on, or in this case, bigger than or equal what it is, right, for Boolean variables. So hopefully this video was useful to you. I'll see you in the next lecture.